Hello. Good. Where are they? Online only 3, only 2. Join now. And here 3. Okay. Okay. Now they are coming. Wow. Suddenly. Hi.
Hello.
Hi, good. Hello.
Hello. How are you?
Yeah, fine. In class, can you hear what they say?
I could just hear her a little bit. It's a little bit low.
Mm-hmm. I will make. Yeah. There is. Just some. Good. Hey, hello online. Say something.
Hello.
Can you hear? Okay, good. When I say something, then maybe echo there. If I say something, then echo there online.
A little bit.
Okay.
Little bit, yeah.
Okay. Last week, I asked you kind of teamwork with 2 cases. Frito-Lay and Hard Rock Cafe. And then compare 2 companies. First one is kind of a production company. Second one is kind of a service company. So find what 10 strategic operations management decision they used, just based on a case. Team 1. The leader is Elisa, right?
Yep.
Is Elisa there? I cannot hear you. Turn on your.
Okay, sorry,
Okay,
I
good.
couldn't find my to unmute myself. I'm sorry about that.
All right, okay. So did you meet your team member?
Yes, we discussed the cases, and we have a discussion document put together. So.
So can you share your finding?
Yes. So we kind of have a lot of information. I'm going to try to give you the most like short version of it, just to not be too repetitive. But starting from your first question that you gave us, how Frito-Lay will handle the 10 decisions of operations management, which is, I'll just list them out for everyone. Number 1, design of goods and services. Number 2, managing quality. Number 3, process and capacity strategies. Number 4, location strategies. 5, layout strategies. 6, human resources. 7, supply chain management. 8, inventory management. 9, scheduling. And 10, maintenance. So
Okay.
as we know, Frito-Lay is more of a goods provider.
Okay, good.
They're about like cost of goods sold. They're not about technically like sales. So my biggest takeaway for that first one, or the team's consensus, was that there is a lot of marketing that goes into this. The design of their different types of chips, even the packaging. So that's more of like a marketing aspect. But what operations management does have a say in is whatever their current launched product is, or any new launches that will affect all the business processes involved. The biggest thing is that point of time in between delivering the potatoes or corn from their supply chain, like farm or whatever, and all the processes up until getting it shipped on the trucks to go out to the different stores. So number 2, the managing quality. This has more of a importance on like the 5 senses. So for them, you want to see the chip, and you want it to like look good, you want it to smell good, you want it to be crunchy, and you want that sound of the crunch, and all those different things that go into like awakening your senses. So when you're dealing with like a product that you're going to be eating. So managing the quality all throughout each of the business processes so that you don't lose any of the quality in those 5 senses is really important for them. The process and capacity, that one, it's just really important that they stick to their time management for each of the processes so that each process is fully optimized and they're not losing any time being inefficient. Also, for the sake of the freshness of the food. The next one for location, Frito-Lay is kind of constricted because they have to be different regional locations, and you kind of just have to go where the food is going to be supplied. So they're constricted to maybe warmer areas where the corn and potatoes are grown. So they have to look at the different maybe tax implications or construction costs or amount of available workers in those areas. For layout strategy, it is kind of difficult to optimize a process where they have to stick to different things for sanitary cleanliness purposes when you're dealing with food. So we can see operations management maybe wanting to optimize this process by cleaning with machines rather than having humans clean, just for less error. But I didn't like read specifically that Frito-Lay was doing that, but that's just like an idea. For their human resources, they treat their employees really great, and they make Frito-Lay a forever company because they offer all types of benefits, and they have the opportunity for workers to grow in the company laterally and vertically with the cross training specifically. The supply chain management for Frito-Lay, there is not too many issues with their vendors, so it is just important that if they did have a circumstance where they have to change vendors, that they kind of come to a agreement with them that there are like different time constraints and quality standards for the corn and potatoes that will be delivered. For the inventory, the just-in-time, those models, and for the material, like I said earlier, since it is a cost of goods sold type industry, it's really calculable. They can see their past performance and kind of predict future performance, and they can gauge better where they can optimize the business processes, like where they have room to do so. So it's kind of predictable and easy to calculate. For the scheduling, like I said, they run a tight schedule for the sake of the freshness of the food. And let's see, maintenance. We kind of just said that, oh, in regards to, not having their production be delayed, shifting, this cross-training, like getting other employees cross-trained to do other jobs. This could help with like the maintenance on their machines. Like if something breaks, they don't need to call a contractor. They could just go to the person inside the company that knows how to fix that issue with the machine. So that's everything for Frito-Lay. And then we go to the Hard Rock Cafe and see how their business model is service type, it's experience that you're receiving, not really a tangible good. So it's harder to gauge. So I just mentioned for the first one that we all mentioned that for the service, they go off of the ambiance and the brand image, which it's pretty much the same for all of their restaurants, but they do customize and tailor specifically to like the region. Like say, for example, the one in London versus one in America, they're going to be slightly different because the crowds will be different. Quality management for them, I didn't want to like avoid talking about COVID, but I think since that's something we all have to deal with now, the quality for this is that they are restricted with the different implications that COVID has on their quality, like, people that are like cooking can't be just like breathing on your food while they're cooking it and stuff like that. So they had to implement more into their daily operations to safeguard against that and let customers know that it's safe. For the processing capacity, they have to adjust to maybe outdoor seating. They have to figure out how the capacity issue will affect them financially. And for location, this is just based off of where they see the most profitable crowds to put their locations in. So mainly like bigger cities. The layout design, which would just be like their efficient workflows, like from the kitchen all the way to the server handing you your food at your table. So in terms of like the outdoor seating or like spaced out capacity, they have to adjust their normal time from getting the food to the table. It's going to be a little bit longer now, so they have to find ways to make that shorter. Job design, basically the people just have to have really good personalities and they have to be able to connect with people and also be efficient workers. The supply chain management, which is kind of difficult for their managing their inventory for the food, but that's kind of something that is always shifting, I feel, but I don't have too much to comment on for that. Inventory management, like I said, for their food, they're kind of just going off of like their suppliers, and there's different demand the more that they customize their menus. Like the case said, like they're moving away from like burgers and now they're like getting seafood and stuff like that. So they have to adjust with like cyclical or, you know, different types of issues with demand and supply. For scheduling, basically, they just have to be flexible, you know, for their business model. And they have to be responsive to feedback from customers and even from their suppliers. And maintenance, basically, there's like not too much. I mean, they just have to have like the upkeep of their restaurants, and they have to, like I said, with COVID, they really have to capitalize on like sanitizing their work areas and stuff like that. So that's that.
Okay. You found too much.
Yeah, there's a lot of detail, but I
Yeah.
don't know.
Good job. Good job. I mean, you found way more than I expected.
Yeah, we have a long write up, so I didn't want to leave anybody's points out.
Is there any problem meeting with your team
No,
online?
no.
Okay. How about any other teams? Is there any problem doing with your team member online? Working smooth?
Not really.
Okay, good. I will share my findings on case. Looks like this. Simple. uh, you know, Frito-Lay and Hard Rock Cafe, similar to your finding, Frito-Lay used 8 of them out of 10. And Hard Rock Cafe, maybe they need a design of goods and service because they sell, you know, did I mention the Hard Rock Cafe when I went it is Venice, Italy. Last year I went to Venice, Italy. Then my son said, "No, I'm hungry." Then where we go? Then he said, "I saw a Hard Rock Cafe sign. Where?" So we found the small. We've tried to find the Hard Rock Cafe, but we didn't have the map in the Venice area, so we struggled. Then finally, we found Hard Rock Cafe there. Only retail store, not restaurant. Usually, Hard Rock Cafe has a restaurant part and then like a souvenir and the cloth and so on. Yeah, Hard Rock Cafe also sells something, uh, food and something. So the company maybe needed design of goods and then quality things and so on like that. But based on the case, basically the case mentioned only 5 things. So the purpose of this case, comparing production and then the service, what they use. So showing the difference, not much, but maybe a certain production company use all 10 strategies. Maybe service company also use all 10, but from the case, some overlap, but some difference like that. So production company and service company may they may use different operations management strategic decisions because of their different business and something like that. So I said, Elisa found more than I expected. Okay, so that is the purpose of the giving you the finding the difference between the production. Okay, any question or any? Okay. And next, today we will cover hopefully 2 chapters. By the way, Elisa, you did a good job.
Thank you.
Maybe next time, different team I will pick. Okay. On schedule, actually supposed to be chapter 3 and 4 tonight, but I changed it. This time, today we had the department meeting. Then university didn't announce how many students, in fact, but some our department faculty members said like 4 of certain faculty members, class students self-quarantine now. That means they are infected or possibly infected. Then certain faculty members said 2 of them like that. And then they said, maybe in 1 month, university change all classes online like that. So we expect like that because University of Scranton, first week 10, second week like 20, 30, and then more and more, and then this week they said about 80, something like that. So we are not safe, right? So anytime we may change online class. So I changed my our class schedule or concept and terminology part first, and then later, if we change, then more quantitative part. So I changed it, and then based on the 10 strategic operations management decision. So 10 strategic decisions first, and then after that, quantitative part, one by one like that. So I change it. Okay, chapter 5, design of goods and service. Okay, design. Why we need design in operations? What in operations management? Why we need design? Why? What relationship between operations management and design? The thing. Yeah. Yeah, good answer. I can say like that. If we design better, then better means like assemble easy, produce easy, fast like that. Then we can save cost. We can save time. We can save such and such, and then make a better product. So better design leads to make it better, cheaper, faster. When I cover this part, then I example Kia car commercial. I don't know if you watch that commercial. You know, uh, the side mirror folding. Have you seen that commercial? In Korea, when we park, then because the park space is very narrow, so between the space between cars, only this space. So many cases park, and then when people come out and hit the side mirror and then brake. So in Korea, it's like mandatory. So park, and then earlier it's like manually fold. And but nowadays just switch, then automatically fold like that. In the United States, is it kind of necessary, or we need that? Usually no, right? But Kia car, Kia Motor automobile company commercial, that our car has that function like that. So in the United States, I don't know if we live in New York City, maybe we need that function, but other than the dense city, we don't need that function. So to make that function, material cost, and then assembly cost, like a labor cost, and then time. And then if it is just manually, when hit and manually fold. So if it uses a kind of electric something and the motor and so on, so higher chance of defect, right? So if the company sell a United States model without that function, then save cost, save time, and then also reduce the chance of defect. So better design leads to the market. Better, cheaper, faster. So design is important in operations management in terms of making better, cheaper, faster. The product design process typically follow these steps: concept development, product planning, product process engineering, pilot production, ramp up. So in this phase, first phase, product architect, conceptual design, target market, and so on. In this phase, they decide what they will make, right? And then product planning, how make it, and product process engineering, detail design, and so on. So how, when, what kind of module they need, and so on like that. And then make a kind of sample, launch, and then if it is marketable, then make more and then sell like that. So many works. If we do multiple jobs, if we have multiple jobs, then if we can do multiple jobs simultaneously and parallelly, then we can save time. Moment. By you, moment. Hopefully work. Share. Share drawing board. Share. Okay. If there are multiple jobs, then work one by one after another. Okay. We call this one by one after finish one, and then next one start, and so on, like that. Then this we call sequentially complete. So one after another, and so on. But if we can do multiple jobs, sometimes simultaneously, sometimes overlap like this, then we can save time. Definitely. Because I have only one monitor, actually two, but then I use like only one, not two. So I do it one by one, so it takes long. So we call that concurrent engineering. Concurrent engineering. If we can do multiple jobs simultaneously or parallelly, then we can save time. We can save time. So when we design something, then try to make the multiple works in the, simultaneously and parallelly, then we can save time. Then we can make it faster. And then cross-functional integration, that means when I cover this part, then not always ask the student like that. If you do, like a conductor do, so 1, 2, 3, 1, 2, 3, 10 times, and then 1, 2, 1, 2, 1, 2, 10 times. If I have only one hand, then I should do 10 times triangle first, and then 1, 2, 1, 2, 1, 2, 1, 2, 10 times, because I have only one hand, but we have two hands. Then I can do simultaneously like that. Then I can do fast. That means to do multiple jobs simultaneously or parallelly, we need multiple workers. So, for example, design and then to launch new product, we need multiple workers from many different departments. Maybe from purchasing department, from design department, from marketing department, finance department, and so on. So make a team and then work together. So we call that team as cross-functional team, cross-functional team, interfunctional team, interdepartmental team, cross-departmental team. And then sometimes we call that team as task force, right? TF. So gather people like experts from each area, gather people, and then we need ask them work together. That is cross-functional integration. So that means we need multiple people from multiple departments. And then open and interactive communication among all team members. Because they are from different departments or functional areas, open and interactive communication is needed. So like you, I made you team for the project the future. So work together. The communication is important. Your team is such a kind of cross-functional team, interfunctional team. So I last week I asked you try team together online. So I asked let you practice with the teamwork and then how it works better. So if we can use concurrent engineering, then reduce time, make it faster, decreasing cost, make it cheaper, and improve quality. Work together and then make it better. So make better, cheaper, faster. Quality function deployment, QFD. To make something customer like, we should know what they like, and then what they need, and then what they taste. To know what they want, what they need, what is their taste, we should ask. Using survey and interview, ask. Getting customers information, that is QFD, quality function deployment. So by asking customer using a survey and interview, no, We get information what they want, what they need, and then what is their taste, and then define, categorize, and so on. That is QFD and benefit. We can make it better, cheaper, faster. Our textbook doesn't say about better, but reduce cost, shorten product time, and make it better because we know what they want, what they need. And then next, house of quality. Looks like house. This chart looks like a house, so we call this chart as house of quality. This one is a matrix of customer requirement information based on customer feedback. Based on QFD, we ask customer what you need, what you want. So based on QFD, we know what they need, what they want. So from their information, if we know they like easy to close, this one is a car door. So customer like easy to close, stay open on a hill, and so on. And then based on their needs, what they like, compare where we are compared to competitors. Then our quality or that function not better than others. We need improve this function. We need improve this function. To do that, such technology we need, then where we are, we have that technology, maybe not, we need that technology to make that. So based on customers' information, and then compare to competitors, and then about the technology, then we know where we should improve. So this one is house of quality and based on QFD. Next one, value analysis and value engineering. This one is cost avoidance method. How simplify product and process. By eliminating unnecessary design features, earlier like in the folding mirror, or earlier when I work at other university, then the chair, student chair, under the student chair, there was a basket. I think that function is leave the student bag on the basket, but nobody used. So that case, that function or that part is unnecessary part. So get rid of that unnecessary part, then reduce material cost, and then assembly time, and so on. And then combine two or more parts into one, cut down the weight. If the product is heavy, then it's hard to move, but make it lighter, then easy to move. And then eliminate non-standard parts. If all parts are standard, then use only one tool, standard tool, then we can assemble with one tool. But standard part, non-standard, standard, non-standard like that, then we should change tool. Changing tool, time. So if we use all standard parts, then use one tool, then save time like that. So before and after, like this, many parts, the same one, but by eliminate unnecessary, combine one and two or more parts in one, and so on. So reduce the number of parts, minimize number of parts, eliminate adjustment, eliminate screw and other fasteners, and so on. Then we can make it better, cheaper, faster. Benefit, reduce manufacturing cost. Because we reduce the number of parts, and then reduce production time. Production time, assembly time to make it faster, and then improve quality. Because we can reduce, if we can reduce the number of parts, then we can reduce the chance of defect. Chance of defect. It's like that. I will use this one. This side. Y-axis is like a chance of defect. And then x-axis is like number of parts. If we increase number of parts, then it's like that. X squared. Exponentially, if we increase the number of parts, then the chance of defect increase exponentially. X power. This one, I don't remember a certain rule. So increase the number of parts, then the chance of defect increase exponentially. So if we reduce the number of parts, then the chance of defect decrease exponentially. So by reducing number of parts, we can reduce chance of defect and then improve quality. That's all for chapter 5. What time is it? Quality management, maybe another 35 minutes. Do you need a break, like 5 minutes? Is it okay? Just keep going. Okay. Quality management, defining quality. Based on a view, we can see quality different. From the transcendent view, product-based view, user-based view, manufacturing-based view, and value-based view. From transcendent view, quality cannot be defined precisely because we don't know numeric data. We don't know numeric data. So we cannot, because unanalyzable property, because we don't have numeric data, and then recognize only through experience. Maybe my experience, maybe others' experience. We don't have numeric data, but we know that is good, that is not good. Quality is innate excellence, like a Cadillac, Mercedes-Benz. Even I don't have a Mercedes-Benz, but people say it's nice and then expensive, so I'm supposed to be nice. and then the company's reputation, and so on. So we know Mercedes-Benz is nice. Like this, if two cars, Mercedes-Benz, whatever, like 500 something, and then Toyota, Camry. What do you think? Which one is better? Sometimes many people say, oh, Mercedes-Benz is better. Even they don't have the experience, but from the company's reputation or commercial and so on like that. So we know, just we know, right? Cadillac, nice car. Earlier, like in 1990s, Hyundai cars, people say, ah, cheaper and not good. Now, Hyundai car improved, but still, some people, because of the reputation. So that is kind of an innate excellence. So that is transcendent view, product, quality. And product-based view, quality is a precise and measurable variable because we know, like numeric data, quantity of some ingredient of attributes. We go market and then grab whatever, then come home and then count or measure. If it says like 10 ounce, measure and then only 5 ounces. What do you think? Not good, right? So based on that amount or quantity, number, we can measure that is good, not good, right? So that is product-based view of quality. And next one, user-based view. User by user may be different, the same one, but this person said, oh, not good. This person said it's good. We go Dollar Tree. Then I like cheap and then affordable. So sometimes I go, but some people, oh, cheap and not good like that. The same one, but user by user, different perspective or quality. So user-based view, idiosyncratic and personal. And manufacturing-based view is conformance quality. Refers to the degree to which the product or service design specification are met. Specification. If meet the specification, then we say it is good. If the specification is not met, then they say, oh, that is not good. So it's like this. Just a moment, I will bring up. if I design a bar 1 inch, then produce and then measure. First one, 1.03. Second one, 1.02. Third one, 0.98. First one is 0.99. Fifth one, 1.05. Sixth one, 0.97. Can you say which one is good, which one is not good? I try to make 1 inch, but produce and then measure. First one is 1.03 and so on. If my specification is exactly 1 inch, then all are not good. But usually in industry, they give like this, 1 plus minus 0.02. Then the range is 0.98 to 1.02. If they are fall in that range, we can say good. So with this design specification, not good, okay, 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 not good, like this, right? So that is conformance quality and manufacturing-based view quality. And the value-based view, do you remember last week we define what is value? Value is price, quality over price, right? Quality over price. So if their quality are the same, and then based on price, higher price and low price, then we buy a low price because value is high. So relative quality is based on price. So value-based view quality is kind of relative based on cost or price. When we design quality, we should consider these things. Performance, that is primary product or service characteristics. If we buy a car, then what you consider? What can be main characteristic of the car? Maybe gas mileage or something like that. And then driving ability, how fast it can go, and so on like that. And features such as sunroof, moonroof, and so on. And reliability, always turn on the engine, then it work always. And then durability, 1 year, 2 years later, just maintain the quality. And then serviceability, if it is a problem, then easy to repair and response. We need something customer service, then response fast, and then aesthetic, something look good, sounds good, and so on. And then reputation, like Mercedes Benz reputation high, and Hyundai law and like that. So we should consider those things. And then cost of quality, when we make a good quality, make better, then we need a cost like this: appraisal cost, prevention cost, internal failure cost, and external failure cost. Appraisal cost, we need test to determine if it is good or not good. Then we need a test. So appraisal costs are cost for inspection and testing. And then if we find something wrong, then we should change or correct the prevention cost. If we find something wrong by inspection or test, then we change, eliminate, redesign, and so on. So they are prevention costs. And the next, internal failure cost, try to find something wrong and then try to fix that wrong, the causal wrong, defect. But still, the chance to make something wrong and then find that defect internally, we do scrap, rework, repair. That is internal failure cost. And then next, we try, inspect, find, fix, and so on, to find the defect internally, but still, there is chance to reach that defect or something wrong to customer. Then we do warranty, replacement, lose of customer because of reputation down, and so on. So there is no external failure cost. So to make better product and then maintain the product quality, we need appraisal cost, what's that? Prevention cost, internal failure cost, and external failure cost, and so on. And total quality management. Earlier, this total quality management was hot issue in management, but no longer, because everybody do. So make it better, cheaper, faster. Everybody do. So total quality management is kind of fundamental now. Or the collective efforts of all managers and employees. Everybody try to make it better. Entire organization efforts. Everybody. And then by TQM, total quality management, if they can make it better, people faster, then they can sell more. So total quality management is kind of fundamental now. But instead, TQM, many companies use this Six Sigma quality. This one is philosophy, and then try to make it better, better, better. Using Six Sigma, six standard deviation. Sigma is standard deviation. So this one is from normal distribution and standard deviation. Yeah, I can use new one. Okay. So standard normal distribution. Minus 3 sigma plus 3 sigma. Then this is middle mean. So if a company use plus minus 3 sigma, quality control criteria, then that means if the company produce 100 and 0.27, that means 97.3% inside, then outside is 0.27. Point, this area is left and right, 2.7%. I'm confused. 9972, 9972, 9972, so 0.27. So 100, sorry. So if the company produce 100, then 0.27, up to 0.7 allowed, defect allowed. 1,000, then 2.7, 10,000, 27, 100,000, 270, and then 1 million, then 2,700, up to 2,700 defect allowed. That means there is too many. So many companies use 6 sigma, plus minus 6 sigma. Then inside is 99.9999999 like this. That means up to 2 out of billion. If produce a billion product items, then up to 2 defects allowed. So by this concept, philosophy, produce 1 billion, then 2 or more, 3 or more defects, then they said, oh, this process has problem. But 1 billion is too many. So many companies use the same concept, 1 out of million. So if 1 or more, 2 or more defects out of 1 million products, then they say, oh, this is not good. The process has problem. So in this philosophy, 6 Sigma philosophy, they try to make it perfect. Many companies, such Hyundai, use this 1 out of million concept. Many companies use ppm, problem per million. So using this ppm, Hyundai evaluate suppliers. For some companies, every year evaluate. Then they give like a 5-star, 4-star, 3, and so on like this. So this is the highest quality supplier. So if they have the suppliers has a 5-star rating, then give them like a incentive, better give them better, faster pay and so on than other companies like in the 3 or lower star companies every year evaluate, but 4-star, 5 stars every 2 years. Every other year they evaluate like that. So Hyundai use this PPM, 1 out of million, 2 out of million, and so on like that. So based on this Six Sigma concept, they control quality. Okay, next. So process that is in Six Sigma control will produce no more than 2 defects out of every billion, or 1 out of million. And single system, this one is fail-safe design philosophy. Fail-safe design philosophy, named by after the Toyota, just in time, co-develop a single, CGO single. It's like this. When we go other country, Asia or Europe, they use different shape of plug. Because in the United States, this or this type, A or B type, 100, 110 voltage. But this type, and then this one in Europe, especially England, British, use this type, 220 voltage. So if we use in the United States 110, 100, 110 something, and then plug in 200, then burn, right? So to prevent that kind of incident, so make different shape. So many different type like this. This one, UK, looks like this. Australia. I've never seen this type. I saw this one, this one, this one, and this one. Korea used this type, this type, 220, so on. So like this, using different shape, different color to prevent, make defect. So for example, certain plant, they have used many different tools, and then they make draw something, and then match that something shape and color. In a hospital, different gas, oxygen, different color. So using different color, different shape to prevent making something wrong. So that is a single system. Okay, and then next one, Tokayoke. This one also fail-safe design concept, or fail-safe quality concept. This one is checklist or special tooling for fail-safe procedure or device. Checklist, usually when we go market, then we have the list. We call the shopping list, right? Buy this one, buy this one, buy this one. If we bring a checklist or the shopping list, then we don't forget, right? Or checklist, do this, do this, do this, something like that. But usually this Pokayoke checklist is not to-do list. Checklist in our life, checklist, shopping list is to-do list, right? But this Pokayoke checklist is usually not to-do list. If you do this, then it can be cause of defect, it can be cause of accident, and so on. So in that plant, don't use cell phone. Don't use that one, don't do that, something like that. So certain area, don't enter without something. Like that. So Pokayoke is usually not to-do list to prevent making defect. ISO 9000, to make something, we need standard. Higher than the standard, then we can say it is good. International standard is ISO 9000. In the United States, have you seen ISO 9000 sign? I didn't, me neither, but I saw ISO 9000 signs in certain Asian country. Bangkok, Thailand, everywhere I can see ISO 9000, 9400, 9100, and so on like that. Why we, in the United States, we cannot see ISO 9000 standard? US use US standard. And the US standard higher than that ISO 9000. So US company doesn't care about ISO 9000. If the US company make something meet that US standard, then don't care about ISO 9000. Anyway, ISO 9000, that is international standard, and then many companies use this standard. Malcolm Baldrige Award, especially for the companies in the United States, promote quality of US companies. So try to improve US companies' quality, evaluate US companies based on these categories, and then give that award. Award winners: Motorola, IBM, Xerox, Cadillac, FedEx, and so on. Ironically, many Malcolm Baldrige Award winner companies struggled or disappeared. Motorola struggled, IBM struggled, Xerox almost disappeared, Cadillac okay, FedEx okay, and many other Malcolm Baldrige Award winner companies struggle. And the service quality measurement. So far, we talked about product quality. How can we measure service quality? Using kind of questionnaire survey, ask these questions about reliability, responsiveness, and so on. Then based on that questionnaire, like using a 5 scale, 1 to 5, and then based on that survey, we can measure service quality. How about e-service, internet, website, and so on, online? Using different questionnaires based on accessibility, flexibility, and trust, security, and so on. So based on these questionnaires, we can measure service quality. We call this e-sub-core, and then regular ordinary service measurement is sub-core and e-sub-core. That's all for chapter 5 and 6. I have you. On Moodle, you have a case. This one is about IKEA. So read this IKEA case and then try to answer questions. Try to answer number 1, 2, 3, not 4, because we don't cover about that yet. So, but I try to answer number 1, 2, 3. This one is about the design. IKEA case. The same. Each person, each of you try to answer number 1 to 3, and then team leader gather team members and then make one team answer. So just practice how your team work smooth online using whatever Zoom, WebEx, or Google Meet, and so on like that. Okay. Any question? Yeah. No. Just practice teamwork. So later, you will develop operations management case, and for that, I just give you a chance to practice with teamwork, meeting, how discussing. Okay. Any question? Any other? Okay, that's all, and then see you next Wednesday. And then try to be safe. Okay. Okay, thank you. Online.
Hey, Professor Kim.
Yes.
I have a question. Who is going to present next class?
You want?
No, who is going to present? Do we have to present or is
No,
any?
no.
Okay,
Just prepare.
okay,
Then like today, I pick whatever team. Then team leader briefly, not presentation, just a discussion. Okay.
okay.
Okay. Thank you.
Yeah, thank you.
Thank you.
Thank you.
Thank you. Good night. Good night. Good night.